Hi, this is Carlos Cousins, and the following is an ACT science test question that is asking us to look at two given variables, in this case temperature and pressure, and try to find them in the tabular and graphic material provided to come to a conclusion. What we want to do here is, do some pattern recognition. What patterns do we see that can help us find out a solution? So here we want to know how the temperature and pressure would have to change in order for a material at point D. Point D is here in figure 1, point D. How can we liquefy that material by increasing the temperature and the pressure? Well, we don't necessarily have any indication here, explicit anyhow, of when the materials are solid, liquid, or gas. But from our knowledge of how pressure works and how temperature works, we know that, let's say, because as we increase the temperature here, the pressure increases constantly. Let's assume that this is one state of matter. As you increase the temperature from a really low temperature to an increasingly higher temperature, we see that at about between 100 and 200 degrees Kelvin, something happens to this material, where part of it all of a sudden shoots up really high and has a lot of a very high pressure. Some of it, however, continues and continues and continues increasing in pressure until sometime around here something drastic happens. And again, the material has a much higher pressure. The temperature is increasing uniformly for these materials as it moves on. Well, it looks like what's going on is whatever we are measuring here is going through a radical change at point E, and somewhere around here where the curve becomes very steep down here. Whatever other material we're graphing here, as the temperature increases, the pressure increases, then at point F, it starts increasing dramatically as well. It seems like some major changes are going on. Well, if we assume that the material continues to be solid at a lower pressure down here for where point D is, right? And we need to make that assumption because we want to liquefy that material. And we know that going from left to right, if you want to make a material liquid, as the temperature increases, it's very likely that a solid will melt and change state of matter so that the pressure changes dramatically, and it might be liquefied. So we would have to change it to maybe look a little bit more like G up here. And I'm picking G because if you look at G, it happens to be at about the same temperature as D, right? We're somewhere in the ballpark of 400, 420 degrees Kelvin. But the difference between D and G, after G has already gone through this radical change that we were talking about here, that points to a state of matter, is G is much higher in pressure. The temperature is about the same. Of course, if we increase both, we might see something similar, but not necessarily at point D. Point D seems to be a point of really big change. Whereas, we can have increasing both at a different point. So consider point B, for example. Increasing both does absolutely nothing. The state of matter remains the same. We might not have liquefied whatever we're considering over here. But over here, you know that all you need to do is increase the pressure, and all of a sudden, we've got a huge, huge shift. So what you want to do is not keep a constant pressure and decrease the temperature. That doesn't really make sense. We're looking at a jump in pressure from a very small increase in temperature for the material over here. So if we increase the pressure drastically, we would achieve the exact same result. Increase the pressure, this is good, while increasing the temperature. This isn't necessary. At this point, for where point D is, the material changes drastically by only increasing the pressure. So that isn't necessarily a requirement. Decrease the pressure, oh well, that wouldn't be a good idea. Then you'd be going down here, which would not necessarily liquefy the material if we're assuming that it started off solid. So that doesn't make sense. And increase the pressure at a constant temperature. This is the answer choice that we're looking for, and this has to be the right answer. I hope that helped with this problem. Happy prepping.